Hello and welcome to Tech Learners. From today we will learn vector integration and our first topic in vector integration is line integral. So in this lesson we will understand first what we mean by line integral. Then we will see what are the uses of line integral and why we compute line integral, and then we will see some examples based on line integrals. So let us start first by understanding what we mean by line integral. Let us consider this is a three-dimensional system. O to X, X-axis, O to Y, Y-axis, and O to Z. This is the Z-axis. So now the line integral will be represented by the component of a vector f in this three-dimensional system. It's the line integral of the component of f along the curve a to b. So this is basically the component of the vector f along the curve a to b. Why we are calculating this? We will learn just after this. So let us say how it is defined. So let's write line integral is equal to the integral of component of f, vector f, along curve AB. Okay, so this is curve A to B. Let me write it in capital. This is curve AB. This can be redefined in terms of the unit vector, which will be dot product of, so this is dot product of the vector f and a unit vector and a unit vector along tangent at a point P at a point P on curve AB. So this can be redefined. The component of f along curve AB can be redefined by the dot product of two things. One is the vector f and second thing is a unit vector along tangent at a point P on the curve AB. So we can see this is a curve AB, there is a point P. Now we need to find out the tangent at this P along AB. So this is represented by PT. So this is represented by PT. Now we need to find out the unit vector of this tangent. What will be the unit vector of this tangent will be represented? You can see that this OP, the vector is represented by R. So the unit vector along this PT will be represented by dr by dx. So this is the unit vector of tangent PT along the curve AB. So let's rewrite this. So this can be rewritten as the integral dot product of f. So this is f dot producted with the unit vector along the tangent. This is dr upon ds, dr upon ds, and now this is the integral. So we need to write ds as the integral part. Here we can see that we can cancel out this ds and this ds, and now finally the line integral comes to be integral f dot dr. Now let us see what are the uses of this line integral and when we need to evaluate the line integral. So we evaluate line integral to obtain the work done by a force on a moving object. So let's say if there is an object moving from A to B, then the force acting upon that will do some work and we need to calculate that work. For that we use line integral. So we use line integral to calculate work done by a force on a moving object or on an object which is displaced from one point to the other point along a curve. We calculate line integral to get the voltage generated in a loop, and then we also calculate line integral to get the magnetic field around a conductor. We need moment of inertia of a wire, and then we also calculate for the center of mass of a wire, or we can also get the mass of a wire. For any of these applications we use to get the line integral. So now let us see with the help of some examples. Let us see this example number 1 based on the line integral. if a force F, which is defined by this two-dimensional force, displaces a particle in the xy plane from a point A, which is 0, 0, to another point B, which is 1, 4. So this can be a curve from A to B, 0, 0 and 1, 4. Along a curve, this is the equation given of the curve, y is equal to 4x square. Then we have to find out the work done. As we have just seen that the work done is equal to the line integral. So here work done is equal to line integral. And how do we define this line integral? So this work done will be equal to integral f dot dr. Now let us see what we mean by f. F is given in the question, 2x square by I plus 3xyj. What will be dr? So here let me write this. F is equal to 2x square y I plus 3xyj. So this is f, and this dr would be as this is in the xy plane only, so dr will be dxi plus dyj. So this is dr. So we'll write f here. So this is 2x square yi plus 3xyj, and dot producted by dr we have already written. This is dxi plus dyj. So this is a dot product. We all know what in the dot product we have I dot I is 1 and j dot j is 1, and rest everything will be 0. So once we perform the dot product, this will be I dot I. So this is 2x square y dx, because I dot I is 1. So this will be 2x square y dx, and I dot I will be 0. And then first term multiplied with the second term will give you a 0, because this is I dot j, which is 0. Next is 3xyj with 3 dxi will be again a 0, because j dot I is also 0. And 3xyj with dyj will give you a 3xy dy. So this is the dot product. Now we need to replace this y and dy by x and dx, as this is a single integral. For that purpose, we will be using this equation of the curve. So here from this we can see y is equal to 4x square. So this is one replacement. We will replace y everywhere by 4x square. We will differentiate this equation. So this equation will be differentiated. So this is dy, and 4x square would be 8x dx. And now this differentiation will help us in eliminating dy from this equation. So we will replace y using this equation by 4x square, and dy using this equation by 8x dx. So let us do the replacement. So this is 2x square dot. Now from y here we have 4x square dot 4x square dx plus 3x dot, again we have a y which is 4x square, and this time we also have to replace this dy, which is 8x dx. So now once we combine all this, we get the integral 2 4s are 8x to the power 4 dx, plus from here we have 3 4s are 12, and 12 8s are 96. So this is 96 x4 dx. So you can see x4 and x4 both are same. So we'll sum this up, and finally this will be integral. This is 8x square. This is 96x to the power 4, which becomes 104x to the power 4 dx. So this is the integral 104x to the power 4 dx. We need to integrate this, for which we need the limits. So we need to find out the limits from the displacement points, and we only need the limits of x. So we'll find out this is x and this is y in this case also. Let's call this x dash and this is y dash. So the lower limit of x will be 0 and upper limit of x will be 1. So I'm just writing the integral here. This is 0 to 1, 104 x to the power 4 dx. So let's integrate. This is 104 x to the power 5 by 5 with limits 0 to 1. Once we'll substitute the limits, this will be 104 1 to the power 5 upon 5, which is 104 upon 5. So the work done comes here is 104 upon 5 units. So let's talk about example number 2. If there is a vector f given by 3x square plus 6y I, this has to be I, minus 14yj, 14yzj plus 20xz square k. Then we have to evaluate the line integral from a point A, which is 0, 0, 0 to another point B, which is 1, 1, 1 along the curve C, where x is defined as t, y is defined as t square and z is defined as t cube. So let us see what will be the line integral. As we all know, the definition of the line integral. So we know that the line integral is integral f dot dr. So this is the line integral. Now here, what is f? So we can see that f here is 3x square minus 6yi minus 14yzj plus 20xz square k. So this is f. Now what will be dr? As we can see, this is a three-dimensional system. So dr will be dxi plus dyj plus dzk. So this will be the dr. Now we have to perform the dot product, and we all know that in a dot product only I dot I will be 1, j dot j will be 1 and k dot k will be 1. Rest everything will be 0. So now let's perform the dot product of this. So this will be integral 3x square minus 6y dx, as we are performing this, and this will be 1. Then minus 14yz dy. So this will be our second term, and the third term will be 20xz square dz. So we can see this is the dot product of f and dr. Now we need to perform some substitutions because this is a single integral and we have to eliminate y, dy, z and dz to perform the integration. For that we will be using these relations. So here we can see x is t, y is t square and z is also t cube. So we'll replace all by t, x by t, y by t square and z by t cube to convert this into actual single integral. And we will be using all these three equations. We'll differentiate this equation x is equal to t, and once we'll differentiate this x is equal to t, this we will get one dx is equal to dt from this equation number x is equal to t. Then from the second equation y is equal to t square, we will get dy is equal to 2t dt on differentiating this equation. Then on differentiating this equation, we will get dz is equal to 3t square tt. So we have x, y, z, dx, dy, dz all in t. Now let's substitute all these values. Here we have x, so this is 3. Now x is equal to t, so this will be 3t square. Minus 6y, so here we can say y is t square, so this is 6t square, and dx will be replaced by dt. Minus, this is 14y, in place of y we have t square, so this is t square. Z, in place of z we have t cube, so this is t cube. Dy, in place of dy we have 2t dt, so this is 2t dt. And then the last term, this is plus 20, in place of x again we have t, in place of z square we have this t cube. So as z is t cube, so z square will be t to the power 6, so this is t to the power 6, and then dz is 3t square dt. Now we'll solve this. So we can say here 3t square minus 6t square will be a minus of 3t square. So this is integral minus 3t square dt. Now here we have t square, t cube and t, which will be power t 6, and 14 into 2, this is minus of 28 t6 dt here. And in the last we have we can say t6, then t square, and then t. So this is t to the power 9, and 20 into 3 will be a 6t t to the power 9 dt. And now we'll take this dt common and we can perform the integration. So next is, this is integral. Here we can solve these two terms. This is 3t square, 26t6 and 60t9 dt. We will take dt common. So this will become minus of 3t minus 28t6 and plus 60t9 dt. So this has been converted into t. What we need limits. So we'll get limits from this. Whenever x was t, then the t would be 0, from 0 to 1. So this is for x. Y is equal to t square. So whenever, so let's say first we will use this x is equal to t. So using from x is equal to t, first when x was 0, we can found t is also 0. Then in this point when x was 1, we can see that t is also 1. So the limits for t here comes to 0 to 1. Now we'll check for the second equation, y is equal to t square. So let's take the second equation, y is equal to t square. Whenever y was 0, so this is 0 is equal to t square, which also means that t is 0. Whenever y was 1, so this is 1 is equal to t square, which again means t is equal to 1. So again for y 0 to 1, t is also 0 to 1. We will also check for the third equation, which is for z is equal to t cube. So let's have z is equal to t cube. Now when z is 0, you can see when z is 0, so this is 0 is equal to t cube, which means t is also 0. And whenever z is 1, here in this case, so this is 1 is equal to t cube, which also give you t is equal to 1. So in all the three cases, we can see the limits for t comes to be from 0 to 1. So here we can write the limits from 0 to 1. Now we simply need to integrate this and then find out the solution. So let's perform the integration of this. So this will be, this is minus of, so this is square, this is minus of 3t cube upon 3, then this is minus 28t7 upon 7, and then plus 60t10 upon 10 with limits 0 to 1. So we can see here this 3 will be cancelled, 7 1 times, and this is 4, and this is 10, and this will be 6. So we'll rewrite this, and just by substituting the limits, we don't have to substitute this 0, so this is 1. So once we'll substitute 1, this will be minus of 1 cube. Then in this case, this will be minus of 1 to the power 7. And here we also have a 4. So this is minus of 4 dot 1 to the power 7. And lastly, we have 6 dot. So this is plus 6 dot 1 to the power 10. So now we have minus 1 and minus 4 and plus 6. Minus 1 and minus 4 will be a minus of 5, and minus of 5 plus 6 will be 1. And there is one correction I have just copied here. It's minus of 6y. So f is 3x square minus of 6y. And here comes the line integral, which is 1. In the next lesson, we will understand surface integral and volume integrals.